All right, welcome back, chemistry. We are still in section 9.3, trying to find our limited and excess reactants. And in our previous lecture, we were just looking strictly at moles. So you were given moles, and you were just using the mole ratio to get to moles of a different product. And I showed you two ways, where method one was you choose a reactant, you use the mole ratio, and then you compare your given with what you need. And then I showed you method two, where you set up two stoichiometric equations and you get to the product, the same product. So like I'd go from CO2 of moles to moles of CH3OH, and then I'd set up my second one with H2 moles, and then I'd get it to CH3O4, and then you just compare the two. So for this, whichever method works for you, you do you. I prefer method two a lot, and I think it's because I just like to do the extra work to make sure I'm right with my answer. And that was the method that I grew up with. So method one is a new method for me. So I haven't really gotten comfortable with it, but I probably will use most of it for this lecture or this video. So today we are going to look at masses. So if you are given an amount in a mass or grams of a product, and you need to get to grams of, I think I just said that backwards. If you're given grams of a reactant and you want to get to grams of a product, you're going to be adding a few more conversions, because to get to grams of one product, grams of one reactant to grams of another product, you have to convert it to moles, then use your mole ratio, and then convert it back to grams of that new product. So let's take a look at an example here, and you might need to cross out a word because I'm not sure if I have grams or moles written on your active notes. But we're looking at aspirin, how it's made from salicylic acid and acetic anhydride. And they want to know, okay, if you're given 20 grams of both of these reactants, what is the limiting reactant? And then for your excess, how much is used when the reaction is complete. So I'm going to use method one here, where you choose a reactant and you get to the other reactant and then compare the values of your given to what you need. So the first step is choose a reactant. So I'm just going to go C7H6O3. Why not? Choose the first one. So I'm given 20 grams of C7H6, off to a great start, O3. And I need to get that to moles, so I can use the mole ratio. So in order to do that, I have to divide by the molar mass. So I got to find the molar mass. Just slide this out of the way. I have carbon, 7 of them at 12.01. I have hydrogen, 6 of them at 1.01. And oxygen, 3 of them at 15.99. And I'm going to add them all up together, and I get 138.1 grams per mole. So that's my molar mass, and that's going to go here. So I'm going to take 20 grams divided by 138.1 grams per mole of C7H6O3. All right, so now I'm in moles of C7H6O3, and I want to compare it to C4H6O3. So I'm going to use the mole ratio. So the coefficients in front of these numbers are both 1. Now I'm in moles of C7H6O3, so that has to go on the bottom to cancel out. And my 1 mole of C4H6O3 is going to go on top. So now I'm in moles of C4H6O3, but I want to figure out how many grams, right? Not only that, they gave us grams to start with, and in order to do the comparison, your units have to be the same. So I'm in moles of C4H6O3. That means 1 mole of that will be on the bottom. And my molar mass of that's going to be on top. So I got to find the molar mass of that. Carbon 4 at 12.01 hydrogen 6 at 1.01, and oxygen is 3 at 15.99. And I'm going to add them all up together. And I get 102.07, whatever. Don't worry about segs, right? So I put 102.07 grams on the top of the C4H6O3. And now my units are going to cancel out. Grams C7H6O3 to grams C7H6O3. I should not have put that moles there. Moles of C7H6O3 to moles of C7H6O3. Moles of C4H6O3 to moles of C4H6O3, and I should be left with grams of C4H6O3. So multiply across 20 times 1 divided by 138.1 times 1 divided by 1 times 102.07, and I get 14.87, 14.78 grams of C4H6O3. So now it's asking me if I want to figure out like what's the excess. Well, I'll compare. So this is what I need. This is what I was given. I was given more, so therefore C4H6O3 is my excess. Okay, so my limiting, because the question really is asking which is the limiting reactant, my limiting reactant is actually C7H6O3. Okay. So how many grams of the excess reactant are used? The answer would be 14.78. And then what's your limiting reactant? Well, I just wrote it on there, C7H6O3. So there's sample problem 1. Let's take a look at another scenario, black oxide of iron. Again, I think I made a typo on your active notes, so make the corrections, please. So black iron is made, in nature it occurs as mineral magnetite. You take red hot iron with steam and you get black oxide. So if we are given 36 grams of water mixed with 67 grams of iron, which is the limiting reactant, well, we can do a comparison, right? So the first step is choose a reactant. Let's just start with water because that's the one that's listed first. 36 grams of H2O. I need to get to moles of water so I can use the mole ratio. So to figure out the molar mass of water, 2 hydrogens at 1.01, 1 oxygen at 15.99. I add them all up together, and I get 18.01. So 18.01 grams of H2O is equivalent to 1 mole of H2O. Now I'm in moles, and I can use the mole ratio. And I'm comparing iron and water to each other. So I'm in moles of H2O. That means moles of H2O is going to go on the bottom, but it's going to be 4 moles of H2O down here to 3 moles of iron on top. And then to go from moles of iron to grams of iron, you're going to multiply by the molar mass. So I'm in moles of iron. That means 1 mole will be on the bottom. And how many grams of iron are in 1 mole? Well, you look at the periodic table. Molar mass of iron is 55.85 grams of iron. Whoops, that's supposed to be an equal sign. I don't know what the heck I'm doing. Okay. Anyways, grams of water will cancel. Moles of water will cancel. Moles of iron will cancel, and I'll be left with grams of iron. So, 36 divided by 18.01 times 3 divided by 4 times 55.85, and I get 83.7 grams of iron. Now this is what I need, and this is what I was given. I'm short, okay? So because I'm short, iron is my limiting reactant, and water is my excess. Okay? So what's your limiting reactant? Iron. Let's move on to the second problem here. What mass in grams of black iron oxide is produced? Okay, so whenever it's asking you for the actual product, you always have to start with your limiting reactant. And we had just determined in this problem that iron is my limiting reactant. So you have to start with iron. And you have to start with this original problem setup, 67 grams of iron. So you start with what you're given. Now I'm going to go from iron to black iron oxide. Okay, so I'm in grams of iron. To get to moles of iron so I can make the conversion, I have to divide by the molar mass of iron. So looking at the periodic table, the molar mass of iron is 55.85 grams of iron to 1 mole of iron. That's how much 1 mole of iron is. I'm in moles. I can use the mole ratio. I'm in moles of iron, so it has to be on the bottom. I look at the coefficients. 3 moles of iron will go down here. I'm going to, I did not fix it here, black iron oxide, or black oxide of iron, whatever. So it's going to be 1 mole of Fe3O4. And they say, okay, what's the mass in grams? So I have to set up one more conversion factor. I'm in moles of iron, of black iron oxide, so I got to get to grams. So got to figure out the molar mass of it. So let's figure out the molar mass. Iron 3 at 55.85 and oxygen 4 each at 15.99. And I will add them up. It looks like around 231.51 grams per mole is the molar mass or formula mass. So 231.51 grams of iron 3O4 goes on top. So my units are going to cancel out. Grams of iron will cancel. Moles of iron will cancel. Moles of black oxide will cancel, and I'll be left with grams of black oxide. So punch it in your calculator. 67 divided by 55.85 times 1 divided by 3 times 231.51 grams gives me a total of 92.57 grams of Fe3O4. So I used my limiting reactant, and I figured out how much product I can actually make with it. Okay. What mass in grams of excess reactant remains when the reaction is complete? Okay, so if I go back to this first problem here, we figured out that iron was the limiting reactant. But I need to figure out how much excess I have. So you're going to basically do the flip-flop of what you did in A. So instead of starting with water, you are going to start with iron, and you'll convert it to water to figure out your excess. So we're starting with water at 36 grams, and we're going to iron. All right, here we go. 36 grams of water. Nope, damn it, I just messed up. That was really dumb of me, because I said the wrong thing. We're starting with iron, and we're going to water. That's what I meant to say. Holy smokes. Okay, so I'm just going to reverse and try again. And I just forgot. Okay, so 67 grams of iron. Here we go. Take 2. 67 grams of iron. And we want to get to water. Okay. So grams of iron, I got to get to moles of iron. I'm going to divide by the molar mass. Molar mass of iron is 55.85 grams. that is equivalent to a mole of iron. Now I'm in moles of iron, and I can use the mole ratio. So I'm going to look at the coefficients. Because I'm in moles of iron, that means it's got to go on the bottom to cancel out. 3 moles of iron to 4 moles of H2O. Now I'm in moles of H2O, I've got to get to grams. So I will multiply by the molar mass. On our previous 2 slides ago, when we started this problem, the molar mass of water, if I remember right, was 18.01 grams. So 2 hydrogens plus 1 oxygen equals 18.01 grams. Okay, so now I am set. I can punch this in my calculator. 67 divided by 55.85 times 4 divided by 3 times 18.01 gives me 28.8 grams of H2O. This is what I need for this reaction. Now, they gave me, and I'll go back, they gave me 36 grams. So, how much remains? I was given 36 grams of water, and I used, or needed, 28.8 grams, and they want to know how much remains, right? So 36 minus 28.8, I get 7.2 grams remain. And my mouse just totally freaked out there, but 7.2 grams remains. Okay. Well, that does it for today's lecture. Make sure you guys reach out with any questions that you have. And yeah, good luck.